Please help me welcoming Babak Pasdar.
Hello. A little bit about my background, as was mentioned. I started out designing large-scale security infrastructure for global firms, Citibank, Verizon, CSFB, UBS, Bloomberg, so on and so forth. And when I got done with almost every project, I looked at it and said, this is insane. What a waste of money. What a useless exercise. How ineffective. And it's just a snapshot in time security, nothing that's sustainable. Also with Verizon, I also ended up discovering the warrantless wiretapping mechanism that the Bush administration had, and I blew the whistle on that. And that translated to the day after I blew the whistle, it translated to a $233 billion lawsuit against the telcos. And I ended up testifying multiple congressional committees, and it all translated into a retroactive immunity bill for the carriers after that. But the objective, and what I'd like for you to take away with today with this presentation, is that there's a whole new compute dynamic that's come into play with crypto, what I call crypto IoT, cryptocurrency and IoT, with crypto IoT. And the traditional security tools that are out there, the traditional security tools that there's a lot of vendors that are in front of you that are selling, are rendered completely useless. They're neutered, they're neutralized with this new technology dynamic. Why crypto IoT, right? Cryptocurrency and IoT. IoT, Internet of Things technologies, are purpose-built technologies. They're purpose-built technologies that communicate. A radio clock is technology. A radio clock that communicates is an IoT. So hopefully that's simple enough. They're purpose-built, usually single-purpose technologies. They perform a task, collect data, or both. They have introduced a new model, what I call a codependency model, right? So your laptop, even your mobile phone, can function autonomously, right? It benefits from the network, but it can function autonomously. IoTs can't. They depend on an application. And because they're highly distributed, that application is typically somewhere else. It's in the cloud, it's in a data center, but IoTs, and think about the Nest thermostat, that's the example I think everybody can relate to. The Nest thermostat is in millions of homes, but the application is in the cloud. It's somewhere else. Moreover, you've got your mobile phone, that's the management platform for it, that is on yet another network. IoTs are typically non-standard technology, what I call imagination-driven hardware, imagination-driven software for imagination-driven purposes. Now, compare that to what enterprises use, which is Intel chipset, Windows, Linux, Mac. I should say Linux, Mac, Windows, just priority, I enjoy them. So that's a little bit about IoT. And what's also different about IoT is that the traditional enterprise technology has a 3 to 5 year lifespan, right? IoTs have an 8 to 20 year lifespan, and that's important. What I call crypto blockchain. It's really crypto technologies. A lot of people know cryptocurrency, Bitcoin, right? Everybody knows Bitcoin. If they understand it or not, they know Bitcoin. Most people could tell you what the value is today, right? Crypto technologies can be a cryptocurrency, right? Bitcoin, Ethereum, Ripple, Litecoin, there's hundreds of them out there. But that's not all they can do. They can also function as crypto transaction. Crypto transaction functions very much like a credit card. It's denomination independent, so it's dollars, Deutschmarks, Facebook's preferred currency, rubles. It can transfer any of those and function very much like a credit card to facilitate a transaction. Now, crypto technologies can also function in a completely non-financial way, which is to validate data. In fact, if there's any takeaway from today, hopefully it is that crypto technologies validate data. At the end of the day, the crypto denomination, cryptocurrency, crypto transaction really is a form of validation of data. An example is, for example, VW. They are feeding telemetry from their cars to the organization, but they use crypto validation to do that. Why? Because they're making business decisions around all of this data that they're mining, and they want to make sure that the data they're receiving is valid. It's not part of some industrial espionage effort to give them corrupted data, right? So in this case, crypto technology is used in a completely non-Bitcoin, non-denominational way. Also, people use crypto and blockchain very interchangeably, and that's okay. However, blockchain is not the only form of crypto. There are other ways. So blockchain is based on what we call proof of, right? Proof of work, proof of burn, proof of stake. You know, basically, it's somebody does the math to make sure that that transaction is valid. But there's other methods like Tangle and Hashgraph that are consensus-based, right? So if there's enough resources, enough participants on the network that decide that something is valid, then it's valid, right? You don't have to do the math. And that's going to play in big with IoTs, because IoTs, as I mentioned, have very limited resources. So doing a lot of hard work is not part of their strengths. Also, there's a term called microeconomy, right? So microeconomy is when you use crypto technology for a particular market segment or for a particular industry. So when you hear about Sunday mornings, IBM's flooded the airwaves with all their blockchain ads. Well, the supply chain model can be a microeconomy where you have a variety of vendors, from the people that provide the raw resources to the people that manufacture, to the people that transport, to the people that receive it and retail it, and to the people who support it, right? They may all end up using a particular type of crypto technology that is very specifically tuned to that supply chain, and that's called a microeconomy. And it can span multiple companies, even competing companies, perhaps. So here's what's really important, and this gets confused in the industry all the time. Crypto is not security. Blockchain is not security. There's a lot of confusing information on the market, and if you thought that, I don't blame you, because there's a lot of marketing departments that pump out a lot of data that kind of allude to it. But crypto is not security. We actually sat across from a VC not too long ago. He goes, well, you know, what you're doing with regard to security, that's kind of old stuff. We want blockchain security. Okay, I'm game. Explain it to me. What is it that you're looking for? Couldn't. Because crypto technologies and blockchain are not security. They don't control access to information. They don't determine if content is well or malintended. They don't keep things private. They don't encrypt. They don't identify. As a matter of fact, crypto does the exact opposite. It's designed for anonymous transactions, right? That's why you can go out there and buy 6 keys of hash with Bitcoin, because it's designed to be anonymous. The person buying and the person selling don't have to know a thing about each other other than, hey, I got my crypto, I gave you your crypto. As a matter of fact, if you go on Silk Road or any of the dark web markets, you literally see like eBay and Amazon style ratings. You know, hey, here's a used gun. All right, it's got 2 murders on it, or here's 6 keys of hash, or here's cocaine. They've got it branded and all of that stuff. They got vendor ratings, the whole bit. It's just that nobody knows who they are. And they don't protect the user. So it's really important to drive that point home. When you see somebody come out there and try to position crypto or blockchain as secure, just know that whoever you're probably dealing with is probably misinformed. So what do IoT and crypto have to do with each other? Well, IoTs are on track to be the largest consumer of crypto on the market, right? So IoTs perform tasks, and those tasks could require validation. Those tasks could require financial transactions. Those tasks could require exchange of funds, right? But, or by the way, it could be all 3 of those. Right? It could be all 3 of those. So IoTs are going to drive more crypto consumption than anything else, and they're well on their way to doing that. And you know, nothing short of the transportation industry, based on the millions and millions of cars they put out every year, you know, that's really driving a lot of it. So we talk about why today's traditional security models, what, you know, a lot of the companies you guys have known and loved for years and years and years, why that technology, why that security solution just doesn't work. So think of it from this perspective. You've got, just like probably many of you, just like myself, you've got all these IoTs in your home, right? It could be the Alexa, it could be the Nest thermostat, it could be your smart TV, it could be the Samsung fridge. Apparently a Samsung fridge is really popular because I've seen it in like 4 presentations so far. You have all that, and you've got your firewall, right? And by the way, this is a home scenario, but it could apply just as much to a enterprise. Well, all of these applications have a relationship to, all of these IoTs have a relationship to an application that's off in the cloud, that you have absolutely no visibility, insight, or control over, right? So now you've got that firewall that's supposed to control flow of traffic in and out. And let's not say it's a firewall, let's say it's a full-blown security infrastructure. But the fact of the matter is, there's an encrypted communication between each of these devices and some application off in the cloud. And moreover, it's managed by a mobile device that's sitting on yet another network. So your ecosystem, your IoT ecosystem, consists of 3 different networks, 2 of which, technologies, but 2 of which you have absolutely 0 control over, right? But have visibility and insight into everything that's happening on the IoT that's sitting on your network, right? And you extrapolate that to the millions, just think of the Nest thermostat. How many millions of homes are those thermostats sitting in? And they're tied to back to one or a group of applications that are sitting out in the cloud. Well, what happens, and by the way, this is one of the scenarios, because all of these IoTs, people have physical access to them. Well, guess what? Someone could compromise the IoT sitting in their home and then be able to work their way backward to the application. But we'll even look at it and say, let's say the application got compromised somehow, right, from your perspective. So what's the next thing that's going to happen? They're going to compromise one or many of the IoTs that are sitting on all the different networks, right? Once they have compromised those IoTs, guess what? Now they have access to every other system that's sitting on that same network. So they can compromise what's called cross-contaminate or cross-compromise. By the way, that's how JP Morgan got blasted. $500 million a year on security JP Morgan spends. And they got clobbered by the Roadrunner website, right? So something that is completely low priority for them ended up having a huge impact on their business. It was a cross-compromise. It was a cross-contamination. And it happens, and then it just expands. So this is why having that security infrastructure does not necessarily offer you any protection. Does not offer you any protection compared to the new model that IoTs have already introduced into your organizations. One of our clients realized that they had 600 IoTs in one of their offices. They bought these, like, their little raising desks. Well, the raising desks, each one of them had an IP address, and they were feeding productivity data, how often it was raised and how often it was lowered. And it was feeding all of that data to some application off in the cloud. They had no idea because IT doesn't necessarily get involved in the everyday, right? HVAC folks within the organization, the facilities folks within the organization make the decision around the HVAC they buy, right? IT doesn't get involved, but guess what? It taps into the network. The furniture people bought the tables, but it taps into the network. So there's information technologies and there's operationalized technologies. And operationalized technologies are going to clobber information technologies in terms of resources that are out there. So when you look at traditional enterprise technologies, it's the gorilla, right? You guys have all heard the term enterprise grade, right? Enterprise grade is supposed to be the biggest, the baddest, the most proven, the most scalable, so on and so on and so on. Well, enterprise grade is the gorilla. What chance does that gorilla have against a swarm of bees? And that's what IoT is. It's the swarm of bees that are going to pester and devastate the gorilla. This is an infographic we put together, the difference between enterprise technologies and IoT. And, in terms of scale, 1 to 100x, and that's going to drive a lot of issues, especially as it relates to IoT. Lifespan, hardware, performance, operating models, physical access, break fix. These are all factors that distinguish and differentiate and make IoT grade a much more challenging requirement than enterprise grade. So let's talk about what you need. There's 4 fundamental security components you need to have base security. It obviously gets much more complex, but from a high level, you need to have identification to identify and to authenticate, control to control access, to control applications and to control content, threat management, and privacy. These are the fundamental base that you need. But when you're talking about tools, security tools today, they fall into 2 major categories. Category number 1 is the gateway tool, right? The firewall that sat at the edge of your network that controlled access in and out to a plurality of devices that exist on your network. When it comes to IoT, everybody's thinking, let's just go on device, right? We'll install the security tools on the device. Well, how much resources do you think a $5 sensor has, right? You think a $5 sensor can do threat management? I couldn't do threat management on a full-blown set of servers, much less a $5 IoT servers, right? So that model is a non-starter. But then again, also think about it. Security tools, security technologies require updates and upgrades quite often. As a matter of fact, honestly, I update our security infrastructure much more than I change my underwear, right? So that, and that's real, guys. You gotta update and upgrade often, very often. So when you put a device out there and you're dealing with a buoy that's sitting in the Arctic Circle somewhere that's talking via satellite, well, that's a challenge. You put a security tool that you can't update and you put it in a device that's got a 20-year lifespan, that's a non-starter. So this is the other challenge when it comes to security. There's all these different what I call silos, right? There's offices times whatever number of offices you have. Data centers times whatever number of data centers. Cloud, SaaS, mobile, remote user, and then IoTs, right? So now you're supposed to go out there and build all of these functions, put together a half a dozen to a dozen security tools that perform a variety of different functions for each of these silos times the number of silos that you have, right? Builds for a complex environment. The enemy of security is complexity. It's not the hacker. The hacker looks at the complexity and weasels their way through the gaps that are generated by the complexity. And this is complex. But this is theoretical compared to what actually is. Things that are out of date, things that aren't updated, things that don't even exist. Technologies and capabilities and security functionalities don't even exist for the silo you're trying to protect. So what makes more sense and what's more logical is that you have a single security utility that can apply across all of your diverse and distributed assets, across all your offices, data centers, cloud instances, SaaS applications, remote users, mobile devices, and especially for all your IoTs. And that way, when you need to update or upgrade security, you don't have this logistics nightmare having to update or upgrade 1.4 million devices of various types that are distributed all over the world, some of which you may not have access to, where if you can't update it, then you have to abandon it and discard it rather than to be able to reach out and touch it. So this is the new and emerging approach that protects the crypto IoT platform. That's it, guys. You made it. Only saw 3 people dozing off, so that's good. Any questions?
What is that one device? What's the configuration of that device that makes it so secure?
Okay, well, it's not a device, it's a utility, right? It's a utility. And it's a utility that's delivered as a service. Same thing with sewer service, same thing with water, right? It makes sense to have a utility, right? And have that utility deliver uniform and consistent security across all those distributed assets. So it does not matter that you got a $5 sensor or you've got a big monster data center application. Guess what? It's same level of security, and it does not matter that that sensor is sitting somewhere you have no physical control or even access to versus the data center where you got armed guards in front, right? So it's a service, it's a utility. So the question was, how do you regulate content out of the IoT devices? There's a functional application for each IoT, right? In one case, it could be smart TV. In another case, it could be a water valve, right? So there's a behavior that you monitor, track, and that's where the application folks kind of get involved. You identify the behavior. You define what normal is, right? Or what a series of normal behaviors are. And then based on those normal behaviors, when you see things that are abnormal, you can make the decision based on volumetric or based on content. If it's, hey, this is way out of whack, I'm going to shut it down. Or this is abnormal, I'm going to alert on it. And I'm going to notify either the user or the operators or both. Or I'm just going to take action because we just can't afford to take risks.
This utility, is it just targeted towards the enterprise, or is the utility available to the individual?
What
well,
we're building,
I'm just saying, is this theoretical or is it real? And if it's real, tell us just a little bit.
Let me put it this way. The 2014 FIFA World Cup games was delivered over this. So it's real. It's real. By the way, the reason they went with a platform that was a high-performance security platform rather than just network was because they had $23 million per second SLA. So, yeah, it's real.
Where does this utility reside if I have an infrastructure that is international?
Yeah, great question. It is globally distributed, right? So it's globally distributed in regions that make sense to have them. And it can be expanded or it can constrict. It can be very dynamic so that you can expand and constrict it as is required. So it's very dynamic. And that's very important to be able to achieve the kind of costs you need to achieve for IoT. When you have 1.4 million devices, then right now, the size organization that has 1.4 million technologies is probably some of the largest companies in the world, right? But it would not surprise me if a mid-sized company at some point ends up with that many IoTs. So it's critical to keep the cost structure in line with what is affordable. Because and I've seen this many a times, the difference between spending money on securing your infrastructure that you just don't see giving you the results or you just don't see the spend ending, organizations would rather assume risk. They start building some firewalls and assume risk rather than spending money. So the solution, this approach, has to be affordable and has to be sustainable so that the cost structure is commensurate with the number of technologies that need to be supported. Cool. Thank you very much. I appreciate you guys having me.